Alright, so it's been a little while and I've made some progress. I've made some progress on this. And I kind of just want to walk through what I made. First of all, I split the backend and the front end. The backend is the bit of the compiler that actually outputs the code. So this has stayed relatively unchanged. We still do order a struct list. Oh, whoops. We order the struct list and we do structs to Validators, and here we could have multiple other methods like structs to Typescript, structs to whatever, like you could do any type. We have a main.go now, for example, where we do all this, right? We take stuff from the backend, order structs list, structs to Validators, and then we output the stuff. Yeah, so that's that. We still give it a manual like project path. So that's something we would I hope to change soon. And in the front end is where things change the most. We now have a like a struct that leads the parsing. So we have a parse factory that creates this struct and allocates some memory. And starts off by consuming the main directory on a given path. So these consume file, consume dir, they mostly just feed this module struct field. So if I show you consume directory, we read the directory, we make sure it's a Go file, we read the file, we pass the file, we get the package name, and then we do consume file. And then consume file takes an AST file and a name and does this stuff, like goes through the AST, goes through the declarations, the spec, the struct types, and does all this. And it kind of adds it to p.module structs. Module structs, if you have a look, is a map of lists. So it's a map of strings. So this is going to be a module name like main, parser, backend, whatever, name to struct position. So it's a map, two maps of actual structs and ordered struct types. And ordered struct types are just the AST struct. So this is very much in the front end phase. We're still using an AST. And we have a couple of stuff like the file it came from, the file name it came from, in which order we saw it, a couple of metadata there. So if I take you through parsing a struct normally, so the parse method, example, just takes the it takes all of the main the main structs, right? Because you point it to an entry file, and it does it whilst we still have memory there. We go for each of these, for the package name and package struct, and we go for each of the structs. We pass the struct. The parse struct goes into a process structs array, and so on. The wheel's done. This parse struct, for example, goes through the fields, goes through parse struct field, so like the individual fields, and here is where it does a little bit more of the fancy stuff. So if it's a selector expression, this means that it is a reference to a dependency. Like, so if it's hello dot something, so we have parse dependency field, and parse dependency field actually must consume the directory of that dependency. So it grabs the path, it consumes the directory. We assign a new map to this package name, because this is a new package name that we found, and what we return is the struct name, pass the dependency field, struct name. Yes, so we pass the struct name, and that's like all we want. So the reason that the thing is, we can actually obtain the name pretty easily. But the thing that we want is we want to consume the directory here, so that later on in our loop down here, we have more things to pass. So I'm using this map as a sort of queue of work to do, right? You have to think of this module struct as a queue of work that I'm pushing things onto that will later be passed. Okay, But that's the dependency field, because if you think about it, the dependency field you don't need straight away. It's just the name of the struct that you're depending from. Something that's more interesting is the past embedded struct field, because this you need to know right away. So what we do is we get the name, we get the ASD, the order struct type, yeah. And what we do is we pass that struct, and this will then, if you notice, create a recursive relation, and you can go far and far as you want. Because we pass the struct fields, and then we return those embedded struct fields. And that's kind of it. Think of module structs as a work queue, as denoted by this loop down here. And each time we go around, we kind of delete one of the structs that we need to, that we have taken care of already, right? Yeah, that's kind of it. Let me show you a couple of working examples. So if I go main, go build and struct type test a.go. Oh, I piped that into a file. I didn't mean to. There we go. We get the standard out of something very straightforward. If we're going to test, we have test2, and we go like, yeah, test2 a.go. This actually has a nested struct type, like a dependent struct type. We even have a very nested dependency there on D. So we do that one, and you notice the topological sort is still figuring things out and working for us. So there you have it. That's the work I've done so far. There are a couple of things I still need to do. There's 3 things I've laid out for V1. Right, a couple of things I'm not going to address is type dependencies on like installed packages for now. So I'm not going to do that straight away. That's kind of, oh, and I'm not going to do type remapping. So if you have stuff like type hello equals int, and you have struct type a struct b type hello. This isn't going to work for now. So those are the 2 limitations that I'm setting. So I think the first thing I want to take a look at is array types. Right, array type seems to be, I think, is like pretty straightforward to start with. And it would be good to start there, because I haven't actually worked on this project for a couple of days, so I need to get back into it as well. I think I might zoom in a little bit more. I think, yeah, this is better. Test array types. So if I have a simple struct of type with array as a hello of string, yeah, it has that. I think that's valid Go code, right? Just making sure. Yeah, that's good. And now I need to remind myself how to do that with can't remember where this was. Testing Valibot, yeah. I need to get some of the array types. So if I have, right, I have this, and I have hello, which is an array of string. Okay, that's good, I think. An array of string. Let's just double check. If I go try and pass a as an incident object of hello, with just hello. Testing Valibot done in SDS. Didn't work, but then if I wrap that in an array, okay, good, it works, and I can have multiple, I assume. Okay. Great. Next, so now we know what to expect. So it's going to be array. Ooh, and I'm not sure which way the array is going to come here in the dependency, but let's do this for now. Okay, and go test dash run test array types. Yeah, test array types. Okay. And yeah, there is not null fill is more complicated. Great. So now we have a test to go off of. We'll have to modify both front end and back end here. And one of the things I want to do is actually show you something pretty cool that I've set up. Let's see. Let's toggle a breakpoint there, and then let's continue. Let's debug test, and there we have. We have a debugger, which is pretty cool. I think this is pretty cool. This will let us really examine the structure of the type. So let's go. Yep. Let's go into that. Okay. I don't know. Yeah. Oh yeah, because I didn't skip over the make function yet. Okay, so we're gonna pass the file. Let's skip over that. Skip over that. Skip over that. Consume the file, and then we pass. Right. Let's go in. And here, go. And then we have a struct name, right, with array. That's a struct type. Yeah, good. That's kind of not the easiest thing to see in the world, to be fair. Let's go into that, pass struct. And then here we go past struct field. Okay, here is where we have to kind of examine things a little bit. What's the field like? So we have, yeah, this is kind of probably hard to see on your screen, but we have a name. That's nice. We do the names here, right? So what I can do is I can, I believe, skip over that. And is it selector? No. Because you are AST filled. It's not a selector, but it is an expression. Right, so there's type expression, data array type. Type expression and then array type. AST.array type, and then to see the data, the array type contains ELT, I'm not sure what that is, element maybe, data, and then that does have the identifier of string. Okay. The interesting thing then will be that we have to see whether you are an actual. Oh no, we don't have to think about that really, because it will be in the main package, so that will be passed. Okay, so we have, I actually have a pen next to me which will help. We have an AST expression which is AST.array type. Okay, so here, if it's not a selection expression, this is the other if that we're going to have to do. Array type, okay, field.type is an expression, and we do AST.array type, if okay. Let's say we have array type, and then from array type we can have the element type. Element type, yeah, okay, that's what it's for. If we had an element type, we could even kind of tie this logic. I'm going to write a comment for myself here. We could then go into the branch above, selector expr, because we could have array of model.hello or something. So reduces complexity, but I'll think about that when I write a test for it. So right now what I want is to have the expression which went into an identifier, as far as I know. Right, so in this branch, which we might extract into a different function to be fair, we're gonna have ident array ident and okay, which is array type dot elt dot asd dot identifier. If not okay, we return field info and then errors dot new. Array type was more complicated to do. Right, we could have a couple of things here that we will have to catch, but not yet. So the array identifier then will have a name. So this will be good. So we're passing a singular struct field here, so we can do a field info, which will have a name of array identifier dot name type oh, actually not sure. Let's see what this one has. The name is the field name. Oh yes, field name. Do we always have field name available? Yes, so we can have field dot name 0 dot name. Where's the? Oh, it's defined down there. Okay, I see. No, we can definitely do it up here. Field name is going to be field dot name 0 dot name. Let's improve code slightly. Field name. And then here, the same thing. And the field type is going to be the array identifier.name, I believe. And down here, we're going to have field name again. Okay, nice. We have a lot of nested ifs and returns, which I'm not super content with. I think this function is the one that's most prone to complexity. But okay, for now I think because it's a series of ifs, we could definitely take this into a switch case, which I think will make things nicer. But okay, see what we have so far then. We nearly get something, but actually it doesn't crash at least. Over here we need to have another boolean, and we're going to have array boolean. Only one can be true at a time. However, this isn't enforced on type level. Consider adding an interface type and do type checking. Just later on in the future. For now we have two variables, two booleans, and I think it's okay to manage, but it will lead to problems later down the line. So then, once I do this on the array type, this is not the array type. This here, array true, and then on the back end, I can do auto struct list. That's still fine. Yep, and then we go here. Let's say here we have a nested object. Field.type, yep. So yeah, that would be a nested object there. Would it? I'm not so sure about that line, but okay. Okay. The next thing to do is we would, for now, with our current test at least, still get the correct JS type. But what we do want is to see we get if field type dot array, we have to treat you differently. We have to treat you somewhat differently. And for now, the only thing I'm going to do. Oh, I hate this. I might change this just now. As soon as I make the test pass, I'm going to refactor some of this. I'm going to say if it doesn't exist, on the index of import validators, the type of array, because we need to import that. And if it doesn't exist, we do add the array. Let's just leave a comment here. To do refactor this logic probably into a map, right? So we never actually have to do an if statement. We just append. And even though it's probably less efficient to not do branching. Oh no, we can still do it. Never mind. Here, and then we still need to check the type down here. And what we'd say is we would go field name and then JS type. Let's actually leave this local valid bot output plus equal this plus this, and then in between, oh god, what am I doing? If field type dot array. Actually, we can do this entire branch down there at least, even though we're going to change some of this. We can do local validbot validators. Let's do plus or equal array, open bracket plus JS type plus this here and a comma in the new line, and then we actually do continue, otherwise we just do that. Okay, what do we get? Okay, we're adding string first, then the array, and that actually makes sense. Yes, great. Object string array from validbot. Hello array string constant. Oh, it's with array. Yeah. Oh, great, nice. So feed working simple array types, and I am just using one branch because let's not get too bogged down with others for now. Okay, test. What should we test? We've only tested string, but to be fair, we know the others work, so let's actually make the other one slightly more complicated. Let's go here and let's say world is an array of float 32. This would be world of array of number. Do you still work? Oh no, because I need to do array and then number here. Good. More complicated test, and then let's actually squash that down and force push. Okay. All right, nice. Test. Test. Struct array types. That's kind of a bit of a weird one. Let's do type for array struct. That's gonna have some field. I don't know, what should we have? What's the data type we haven't had in a while? Let's spice things up. Let's do type. No, let's just leave it string. Whatever. And then with array, it's gonna have a thing at some field. No, for array. There we go. And then here we're gonna have const for array is equal to object. That's gonna have some field. It's gonna be a string. And then with array, it's not gonna have that array of for array. I think that's correct, right? Const equals object world is string, and then here we can just do B. Yeah, that works. Yeah, we're kind of focusing on validbot right now, but just because it's the use case I want to use. But this could be anything in the future. Like, doesn't just have to be restricted to this. Just to see what happens. Let's run test struct array types. Yeah, so it does something. It doesn't quite work though. I think it's all in the front end now. No, all in the back end now. So if yeah, because it will be up here. Here we must have a nested object. Yes, but local valid bot output plus or equal this. And let's get rid of that. And then in here, we're going to have to do that really ugly inserting of the array thing again. Oh, and I hate this. Okay, well, look, it's okay for now, but not okay in the future. So if field type dot array, we push that into the importers. And between here we do local valid bot plus or equal to array open plus field type plus or equal plus and then we continue. That's super ugly. Yeah. What's wrong then? For array, object sum field string. Oh, there's a missing semicolon. Awesome. Fit working nested. Working array for same package structs. Great. Oh wait, but okay. I'm gonna refactor this now. And actually, you know, just a good practice, let's just run all the tests, and whoa, we get a failing somewhere. We get a failing on test embedded struct. Seems to have broken something. And what have we broken? The stack trace points to 191. Oh, right, because of the embedded types. Yeah, okay. Right, I kind of see why I can't quite do what I wanted to do there. Let's just locally declare this for now until we can sort it out better. You're okay now. Run them all. You're all good. Fix broken test. Broken embedded structs. Okay. Nice. Nearly there with array types. The only next thing I kind of want to support then is test nested struct array type. And this one can't be tested in this package. It can be tested here though, because this one actually deals with files and it makes a bit more sense to put it here. Alright, so then what we're going to do is we're not going to write the Go code here. We're going to write it in tests here. We're going to write test3/a.go. We're going to write nested/b.go. It's going to have package nested. It's going to have type I am nested struct. And let's just give it some string field int, another one for good, for luck. Let's do an array of string. Why not? and we go here and we go package main, type testing structs. It's going to have nested array, which is going to be an array of nested struct. Some other field float 32, just because. And then here, which is I think the correct place to put it, we're going to have there we are. We're going to have the const I am nested object some field number, another one for luck. It's going to be an array of string. And just to get the inputs right, we got string, then we got number, then we got not number, no, and then we got array. And here we have testing struct nested array, which is an array of I am nested some other field, which is going to be a number. Okay. It's not going to be a code pass, it's going to be a main pass. Vali.string, vali.string, yeah, okay, so this is going to test 3a.go, that's the package name, we're feeding it manually, but it should come from go mod eventually. Go test dash run test nested struct array types. There is not role. Array type was more complicated to do. Yeah. That's right. So on the front end, the reason this is happening is because we can go into here. I mean, we can go into the array type. And then some of this is related. So I think what I should do actually is gonna make a method. It's gonna be pass array field, and it's gonna take the same like interface as these functions. It's not gonna be an AST field. It's gonna be AST dot array type. And it's going to return an array of field info or an error. Make this a little bit bigger. Where what we do what we do is we know we have an array and we can have we can probably call what is field dot the expression here, yeah, because what we do in here with the struct type is we have type expression and then type expression. Do we ever just use field on its own? We use field on its own for names, but not quite for the field. So this is a good place to again get another function. Let's call it func p parser, and the purpose of this function is to be parse struct field type, and it's going to take not a field but an expression. Yeah, it's the expression. It's going to return the same thing. And what this is going to do is, first of all, I'm actually going to comment out the function declaration for parse array field. I'm going to leave the code as is. But in here, I'm going to do a couple things. Yeah, this one could actually go way further up, I think. So first modification is return this. First modification I'm going to do, field type identifier dot name. Oh, okay. Oh, but one thing we don't do is I just thought of another edge case, which is embedded structs of nested fields, nested packages. We don't deal with that very well, so I think we'll take that soon. Do this and yeah. Okay. First of all, switch on. Oh god, not you. What the hell was that? AST.switch statement. Oh, fair enough. Switch on fields dot type. Wait, how do you do that? Golang switch case on type switch statement. Oh, switch v is equal to, okay, switch t is equal to, right, field dot, I think it's, is it type they called? Yeah, great. So curly braces, type is not an interface. What's this talking about? Type, oh, it's not a star, it's just this. There you go, got you. AST dot, let's do the identifier first. Yeah, the identifier first, which will actually have include the embedded ones. Field type, what is this? Oh, it's the identifier. What is field dot names? Oh, so this can definitely be on its own down here, because it's not so much a type, because there's no expression. So maybe it wouldn't be correct to put it on the other one. So again, first thing I'm going to do is actually take this part of the code and move it way further up. So it'd be the first statement, field type identifier. Oh no, oh god, I keep forgetting, because actually we rely on field type being an identifier. So now I understand you. Okay, so if but here we require fields.name. Oh wait, no, if fields.names is 0, then we can only have an identified expression. So, god, this happens sometimes in programming where you like think of a conclusion, two different conclusions, and you think one is right, but then you realize it's wrong, and you think the other one is right, and you think that one is wrong again. Like you go back and forth so much on stuff like this. So I'm gonna go here. I'm gonna take that. Field type identifier dot name. But actually, you just go on fields names. Like we can just do this and put it up here. And we go, well, if fields names equal to 0, then we're guaranteed for this to be an identifier. Correct, right? Can we have type A struct array type B struct hello string. We can't just have this. Yeah, this is not great. We can have B. What we can have is, I think, a selector expression. We can have, field name than this. This is more complicated. Has to be either ident or selector expression. For now, we only deal with idents. So field.type.st.ident identifier field ident and OK. If not OK, we return field info errors.new embedded field was more complicated to do. So field identifier now. What does parse embedded struct take again? Take the struct name. It's going to be field identifier.name. As far as I know, you're okay. Must be an embedded struct. Let's do embedded struct check. And we return, yeah, no, it won't be seen again. And now we can actually do field name is equal to field.names at 0.name. And here we go, we can get rid of that. We can get rid of you. And now, I think we can go up here and finally start our thing. So, if you are an identifier, then we just return the field name. Let's go field name as well, string and a field. And actually, oh god, I jumped too much. It's just field name and then field type, which comes from identifier.name. Yeah, this one's easy so far. Yep, field name. Oh, what's this? Wait. Oh, because there's a colon there. Don't need that. T.name. Case. So that's one done. Let's do the selector expression next. Case ASD dot selector expression. Can we do return p.parse dependency field? Oh no, we can't. We have to do p.parse struct name and an error. Parse struct dependency field. If we could get it to yeah, this is what I'm gonna do. I'm gonna change parse dependency field to actually be cleverer and return an array of field info so they have common interface with the other ones. I'm gonna do a field name. Let's add a field name there. Don't need you. Field info like this. Array of field info like this. And what it's going to return is an array of field info with name of, what was it? Struct name? No. Oh, it is struct name. Where do you come from? Oh, there you go. But that's actually the type. The name is going to be field name, and then the type is going to be struct name, as far as I know from down here. Yeah. Great. So now, what we can do use? Hopefully get rid of use. So we'll get rid of in a bit. Let's do p.parse dependency field ordered struct field name p dot just t. There we go. Now we have common interface. Really, really nice. And then last one is the one that we just added, which is ASD.arrayType. And array type is going to be here. And actually, I'm just going to add this comment there. Array type just gets ELT, which is an identifier. Oh, I know what to do. I think we can do return p.parse struct field type recursively with the ordered struct, the field name, and the t.elt, and hopefully, and if we go here, we go field info errors. Is there a default case maybe? Oh yeah, if I have default, we can just put it onto one statement. Really nice. Errors.new current. Let's do. Can I do new f? No, I can't. I can do. Well, I can do fmt.sprintf. Cannot. Do not. Currently, we don't support types, and here we can do what is it? Field EX expression. There you go. Very nice. I like this. It's pretty. Hopefully, we can just get rid of you. We check the field's name is bigger than, and then we do return. Could even call it. Oh wait, okay, hold on. Let's not get too hasty. So we have the field name. Yeah, so let's do return parse struct field type. p.parse struct field type with the ordered struct, the field name, field.name 0.name. Then we don't need a local variable. The compiler would definitely optimize that, but okay. And then field.type. And then we have this like little in between that just kind of does a little bit of error handling. And then it passes the correct things to this. Then I never need you, because array type just goes on this. Cool. Well, now we need to check that it works. Let's actually just do run on everything. Okay, stuff breaks. But what breaks? The test nested struct array types, and then the test embedded structs also breaks. Okay, let's do the embedded structs first. Test embedded struct first. Oh wait, yeah, I messed up again. Because I can't just do fields.name 0 here. Oh yeah, I've just completely forgotten about embedded structs. Let's do if the length of field.names is equal to 0, we do return p.parse embedded struct field ordered struct name. Struct name. I think it's. Oh, I need to force it to be an identifier. Yeah. Identifier is equal to field.type. ast.ident, not ident. If not okay, return field info errors.new. Do not currently support non-ident types embedded. And now we can feed it the identifier, which I think is what it wants. Pass embedded struct. No, it wants struct name, which is identifier.name. Okay, nice. Let's do the rest. So we get a couple things that fail. Test array types, test struct array types, and then the test nested struct array types. So all of our array stuff is failing. Let's do the simple one, which is test array types. Yeah, I guess it isn't, because we're not setting. Oh, we need to actually intercept it a little bit. Yeah, field error. Yeah, if error is not equal to nil, return field error, but otherwise field at 0 dot. Wait, what's field again? Field info. Yeah. Field info at dot array is true, because we can only have, one of those. Now we do return, fields and error, which should be null. Great. Okay, only one failing now, and this might be a pretty okay one. What is this? Test nested struct array types. Test nested struct array types. Test 3, we have B. Oh, this is the package. It's also getting the rest of the package, I think. So it's going. Oh, wait, no, that's not right. Is it? It's giving test struct, which has nested array, which is an array of nested struct, and some of the field number. Yeah. And then. Oh, I'm importing the wrong thing. It should be test 3. I am nested, yeah. String number array. I am nested. Another one for luck. Yep. Oh, it needs a comma there. And it's not this. It's going to be array of you. Okay, what else? Nested array. Oh, colon. Yeah. Felt like I was writing Go then for a second. Very nice. Feat / refactor reworked getting array getting struct field. Really nice. Quite happy actually with this function, pass struct field. The only bit of complexity is this, which is a little bit ugly, but I guess I could extract it into one other function. The thing I'm kind of there's a lot of function with the same signature, which I think is great, but I wonder if there's like a better way of putting this on the type level. I mean, the Java way would be like, make an interface and then implement it on classes for each individual thing, but that just sounds bad, right? Where I could just keep to this pattern, which, sounds pretty good. Nice. So that is all working, and my functions have gotten quite a bit smaller. I'm not much of a one for like a sucker for clean code, but like you can appreciate it when it's there, right? Like small functions that all do one thing well. I think I'm starting to reach that point on the front end now, where things actually are really nice. At least they look really nice. The code seems good. But yeah, there's like, for example, these. I'm happy with it. I'm not gonna say I'm unhappy. Like you have ordered struct, which I mean, where the hell are you used? To be fair, you are used here. We pass an ordered struct to here. Where else do you use it? You pass it. I mean, you have to pass it through. Oh, it's on dependency fields, right? And the embedded one as well. Okay, so it is needed. And then the other bit of complexity is here with pass struct field, where we can pass a field, or we can pass it if it's embedded. I think I'm going to tick that one as done on array types on my work list. And that's all the features I'm going to do for today, for now. This does leave map types, right, and anonymous types. Anonymous types I think will be quite an interesting bit of work because it will be basically one big recursive function, I'm pretty sure. But what I'm going to do is I'm going to tackle struct the Valibots. This is grim. This is not very nice. This is not a very nice function at all. So what I'm going to do is well, change it, I suppose. Yeah, I think this for loop is fine. This is not so fine. This is not great. Yeah, we have import value. Yeah. And what I'm gonna do is I'm gonna have type, because we need to keep order, right? We want deterministic output, and then a map, we wouldn't get that. So we're gonna get ordered string, which is just gonna be struct that has an order, which is an int, a uint even. Order of uint, and then value of string. Here we go. Ordered string, and let's just make map between is string. Oh, let's make a map between a string and a number, I think. And then we can yeah, that's the best way to do it. I think we have a value from string and a uint. Imported validators, we can say at object is equal to 0. It's nice. And what we can do is field.type. Yep. So if there is no type, but you could be an array. Get array. I guess we're going to follow a similar pattern. We're going to do func get single fields, and it's going to take not a struct list, but it's going to take a struct. Let's do s struct. It's going to return a string or error. Right, and here we're basically going to copy this here. Let's not delete it just yet. Field type. Oh no, it's not a struct. It's actually going to be just not field info. It's going to be field info. Field info. And here field type into field. Local valid bot output is this, but actually you're going to be local valid bot output. Get single field. And I guess we want to pass the validators as well. Validators, which is a map of string and uint. Validators, validators, validators. Oh, and you don't even have to be there anymore. So what is going to happen is, if you are an array, let's make a really small function called append if exists. Let's do maybe append, or maybe add. We're going to take validators, map of string and uint, and it's going to return nothing. We're going to say, oh, we're going to do we do need a counter, I suppose. Validators, counter uint, and then field string. If what would it be? Fee and exists. Actually, just underscore. Validators at the field. If it exists, we return. Otherwise, we do validators at the field is equal to a counter plus plus, and let's make you a star. Just so we can pass by ref there. Here we can actually just return. Return local valibot output, and yeah, cool. And in here we do maybe add. Here we also have the pointer to the uint. Maybe add onto validators counter, and this is going to be array. Same thing here. We do maybe add onto the validators the counter, and it's going to be the JS type. Okay, so that's that part done. Otherwise, if it's an array, then we do maybe add the array. Otherwise, we return local valid output, and yeah. Okay, I mean it's not the prettiest of functions, but I think it'll work. Counter is equal bar counter uint is 0. Oh, it is 1 because we need to start it before. Okay, so let's delete inside here. Field output error is equal to get single field. Let's point it to imported validators. Does that copy the map? I can't remember if it actually copies the whole thing from memory. or not, the pointer to counter, and field type. If error is not equal to nil, return this an error. Otherwise, local valid bot is plus or equal the field's output. The import line here is here we do key and value. And actually we must do map validators array, which is make of an array of string with a length of imported validators. Let's put you there, and then for key value we're going to do validators. Let's do index equal to 0. Validators array at the index is equal to the oh no, not an index. Yeah, then that's the whole point. The whole reason the value is equal to the key. Very nice. And then that is sorted, like that's a sorted array. There we go, for underscore validator in the range of validators array, import line plus or equal to, is it just validator? Okay. This breaks because it does validate, no, yeah, we've got to do plus comma space, something like this. Okay, mostly happy, but tests are failing because object string number array. What is this? I am nested. Where are you coming from? Where is the name? There is something fishy going on with nested stuff, especially nested arrays. What did we have before? Oh, this is such a confusing diff. That's really annoying. But if we go into test nested struct array, then we can test. We do wait, is this it? Test nested struct array types. Oh yeah, for that top one, I was looking at the wrong file. We get the I am nested, some field, another one for luck, good. And we get nested array, I am nested nugget. I am nested is just coming up, like sneaking its way in somewhere. Somewhere. Is it from here actually? fnt.print line field output. I could do a debugger right now, but yeah, there's a full array somewhere. So it would be here, right? Print line local validate output. What? Oh, Oh, I see. Look at this, yeah. We must return local valuable output nil. Then it works. Nice, and that works. Alright, and then this is refactor front end code to be nicer. Alright, we'll call it there with today's video. This was really good. I haven't been into this project for a couple of days. It's been busy, quite busy with work. But really happy with the progress so far. It's turning out to be a nice project, and I think finally I have a code structure I actually enjoy with this front end. Like it's nice. It's like what I wanted it to look like from the start. It took us some time. You know, you don't really know what you're building. So I have array types done today's video, which is good. Under the scope that I said at the beginning, right? No dependency fields and no type remapping, stuff like that. We need to do map types next time, and then also anonymous types, which will be a challenge. And then also the bugs that will sneak in along the way, which I'm sure will happen somewhere. But anyways, it's been good. Thank you for watching, and I'll see you in the next one.